Previously, we explored the full sample space for two fair coins. Here, we'll discuss the associated probabilities. The sample space video is listed in the description. Highly recommended before you start. First, we'll determine the basic probabilities for two coin tosses. Then we'll solve more complex problems built on them. Let's solve these probabilities first. As we know already, this is single gold coin and this is single silver coin. These are the two sides of the first gold coin and these are the two faces of the second silver coin. Here is the sample space for tossing two fair coins, as shown in the previous video in a uniquely beautiful way. Probability equals number of favorable outcomes divided by total number of equally likely outcomes in the sample space. Now, we calculate the probability of two heads by listing the favorable outcomes in the numerator and the total possible outcomes in the denominator, as shown. Thus, there is one favorable outcome and four total outcomes, so the probability of two heads is 1/4. Next, we compute the probability that at least one coin shows a head. While the example is simple, the underlying method is the same for all similar problems. Adopt the complementary counting approach. Count outcomes where the event does not occur, then subtract from the total. This represents the complete set of all possibilities from which this particular outcome is to be eliminated. Out of four total possibilities, only one outcome contains no heads. By subtracting this single unfavorable case from the total, we find there are three favorable outcomes that include at least one head. Thus, the required probability that at least one is head is equal to 3 divided by 4. Next, let's calculate a new probability. We'll define two separate events. Event A, the first coin shows a head. Event B, the second coin shows a head. We are going to find the probability of A union B. A union B, which is simply the chance that at least one of these events occurs, meaning either the first coin is a head, the second is a head, or both are. We will now list the specific outcomes corresponding to event A, first coin shows head, and event B, second coin shows head. To visually determine the favorable outcomes, we will now represent the possible scenarios within a Venn diagram, placing each outcome into its appropriate section. When representing the outcomes in our Venn diagram, the outcome H1, H2, where both coins show heads, satisfies the conditions for both event A and event B. Thus, it is placed uniquely in the intersection, ensuring it is counting only once. And the required probability is calculated as usual. Thus, there are three favorable outcomes and four total outcomes. Thus, probability is 3 upon 4. Now we will solve one conditional probability. For our analysis, let the event C signify the occurrence of at least one head. Initially, the unrestricted sample space contains four possible outcomes. However, the given condition that at least one head has occurred restricts this space. We must therefore eliminate the single outcome that contradicts this condition, the occurrence of two tails dt. This outcome is no longer an element of our new reduced sample space. Thus, this is our new sample space. Now, within our reduced sample space, we will calculate the probability of the event that exactly one ED occurred. The favorable outcomes satisfying this specific event are T1H2 and H1T2. Thus, required probability is equal to 2 divided by 3.